Hello everyone. My name is Uwais. So today me and my team will be presenting about the topic application of differentiation with the subtopic related rates. So our group members are Tuan Mohd Idris Irfan bin Tuan Muhammad Azahar. Second one we have Syed Umar Yahya bin Syed Abu Bakar, and last but not least is me, Uwais bin Romzi. So now moving on to the introduction of the related rates. For the introduction of the related rates are rates of change associated with two or more related quantities that are changing over time. So for those of you who don't understand, let's take an example. A spherical ball is being filled with an air. Both the radius and the volume of the ball are increasing. So arguably the rate of change in the volume, which is V, is related to the rate of change in the radius, which is R. So in this case, the rates of change of the volume, which is the dV over dt, and the rates of change of the radius, which is the dr over dt, are related rates because V is related to R. Moving on to the problem statement. A spherical balloon is being inflated at the rate of 8 cm per second. Determine the rate of change which the radius of the balloon is changing when the radius is 10 cm. So from the problem statement, we can already conclude that the rates of change of the volume of the spherical balloon itself is 8 cm to the third power over second. So I'm just gonna write down here. So the dV over dt is 8 cm to the third power over second. And also from the question again, we can already see that the radius is 10 cm. So I'm just gonna write down here the radius is 10 cm. Now what is left is the rates of change of the radius itself, which is the rate at which the radius of the balloon is changing, which is the dr over dt. So these are all the information we can take from the question. And from this question, there are two ways to solve this kind of question. The first one is by using the chain rule method, and the second one is by using the implicit method. So now moving on to the chain rule method, which is the method number 1.
Now is for the solution. We can use two methods to solve for the answer. The first method is by using chain rule. From the question, we know that the balloon is sphere. So we need to use the formula to get the volume of sphere. As we know, the volume of sphere is 4 over 3 pi r cubed. So V equal to 4 over 3 pi r cubed. Also, we already know these two information, rate of change of volume and radius. But we didn't know the rate of change of radius, that is dr over dt. For dV over dt is equal to 8 cm cubed per second, and the radius is 10 cm. Then we need to differentiate the volume formula. So dV over dr equal to 3 times 4 over 3 pi r to the power of 3 minus 1. So we will get 4 pi r squared. Next, we can use this formula. The formula is dV over dt equal to dV over dr times dr over dt. So we can do like this. We can cancel out dr from both dv over dr and dr over dt to get dv over dt. Now we can solve for the answer. To solve for the answer, we must fill in the formula by using the value that we have. So we have dv over dt, that is a, and dv over dr, that is 4 pi r squared. So 8 equal to 4 pi r squared times dr over dt. Next, 8 equal to 4 pi 10 square times dr over dt. We have 10 because the value of radius is 10 cm. Then we need to rearrange the formula and we will get dr over dt equal to 8 divided by 4 pi 10 squared. dr over dt equal to 8 over 4 pi 10 squared. We have two values that we can cancel, that is 8 and 4. So 8 will become 2 and 4 will become 1. Therefore, dr over dt equal to 2 over 100 pi. Lastly, we will get dr over dt equal to 1 over 50 pi centimeter per second.
Assalamualaikum. My name is Umar and today I will explain to you how to solve this problem using a method 2 which is implicit. Okay, firstly we know that the balloon is sphere, so we already know that we need to use the volume of sphere, which is this one. And from the question also, we got the dvdr which is 8 and the radius is 10. So we got a lot of information and it's easier to solve this problem. Firstly, we need to differentiate the volume of sphere because the volume of sphere is dv dt and dv dt need to multiply with dr dt. So after we differentiate the volume of sphere, we got the dv dt which is 4 pi r to the power of 2, and we arrange all the information like this. Firstly, we need to arrange the dv dr which is 8 equal to dv dt divided by dr dt. After we arrange the equation, we can arrange like this because the dv dt need to divide it with dv dr. So after we arrange like this, we can simply cross the 8 and 4 because 8 and 4 can divide, and we got the 2 over 10, 2 over 100 pi. So we can simplify the 2 over 100 pi, and we got the answer is 1 over 50 pi centimeter over second. So the answer is the same as the method 1, but the method is a little bit easier. That's all.
Okay, so now with both methods have been explained, let's jump into the conclusion. So now in conclusion, there are two ways to solve related rates question. So the first one is by using the chain rule, and the second one is by using the implicit. Okay, so with both methods have been explained, I hope students will find both ways easy to use and understand. I hope our explanation about related rates is clear and easy to understand. Thank you so much.